Hello everyone, welcome to another electrical energy consumption related data analysis project. Here we are doing appliances energy analysis prediction. So over a given period of time, we will see energy consumption by quarter and month. When the inner temperature is more or less, what is energy consumption, how it varies, and the data is coming from different sensors that are placed inside. Then outer temperature based energy consumption when atmospheric pressure is high or low, average energy consumption by light load, energy consumption by relative humidity outside, relative humidity inside. So we have different parameters here. We are just considering one sensor value here. When months, for different months, what is the temperature as per the data set? And on the basis of rising or decreasing temperature, how energy consumption rises, we can get some insights from here. Energy consumption by wind speed, by visibility, by t dew point, and some random variables. We will see how to create these simple groups and create these bins to see the distribution. Everything which is shown here, and some insights about what is the data set, how to download it, how to use it in Power BI will be discussed in this project. So let's get started. So the data set that we are going to use in this project is appliances energy prediction data set. It gives us electrical energy consumption analysis, or it is suitable for this purpose. In the data set, let's see first. So in the data set, you can see we have information of date, number of appliances running, number of lights running. This is temperature, relative humidity, temperature sensor to relative humidity, and so on. So in the data set, you can see these are indoor temperatures in degrees Celsius, and this is indoor relative humidity, the RH1, RH2, which is coming from the sensor, and it is given in percentage. So this information is given in percentage here. We also have the outdoor temperature as T out. So wherever you will find T out, this is the outdoor temperature. Currently this is given as 6.5999, so we can probably round this value, which we will see. Then we also have other variables like lights, also recorded separately but usually a second target. So weather related variables are visibility, pressure, wind speed, etc. And date field is given as date time. Pressure is given in mmHg, wind speed is given. So this is a very useful data set when you want to do regression task like predicting energy consumption, time series forecasting, or feature importance analysis like how much weather impacts indoor appliances usage. This dataset is easily available on UCI machine learning repositories, and in this dataset the field appliances is our target field. So number of appliances here, and based on that its unit is watt hour. So a watt hour is a unit of energy, it is not unit of power. It represents the total amount of energy transferred or used when 1 watt of power is maintained for 1 hour. You can think of it as measuring the work done over a period of time. So with this data set, let's start analysis. To start analysis of this project, we will open Power BI desktop. In Power BI desktop, we will simply click on get data. Since the file is a CSV file, we will simply connect that particular file here, and from UCI repository, this is a CSV file. After loading the dataset, first we will add a text box. So after we will get the data, we will go to transform tab just to see what are the data types. If needed, we can change. So you can see this is being read as a date value. If actually you will go to change type, you can see it is automatically read as date time. This is something that I was mostly interested in seeing. All other values are numerical continuous values and they are being shown as float or integer values. Now we will simply close and apply. So changes are being applied. Let's wait for that time. Now we will click on text box, and whatever you are trying to do, you can do it here. So let's align the text box here, collapse that filter, and here we are going appliances energy prediction. So appliance energy, basically analysis and prediction. Prediction is something we will do later. First we will do exploratory analysis. We will try to understand what features are important, like what features have what kind of effect on our target field, that is appliances. And here we are going to use a color, or actually the color accent that I want to use is this color. uh, Obviously you can choose any other color of your choice, so I'm just going to choose little bit dark of this color. And for effects I will go to shadow. For shadow also I will choose the same color, and maybe not for shadow, let's select that dark color for shadow, but for border, yes. So for border I will select this and rounded corners. So this is my heading here. After writing the heading I will also add some icon here, an icon that represents appliance energy consumption or something. So for that I will go to insert image. In my drive I have some assets and I have made the icon using Canva in the same color. That's why I decided to go with this color. So here I mostly use this sidebar for filters, although here all the numerical values are there. So we'll see what filter do we have to give for exploratory analysis. Then select this, go to home tab, format painter, and apply the same styling here as well. So this is our appliance energy analysis prediction headers are ready. Now we will save the data and we will save it inside the appliances energy part. And here I will just rename it as UCI because data comes from UCI appliances energy prediction. Now let's start analysis. We will create a simple chart. We will use line chart here, and using the line chart we will try to create date wise appliances to see if it changes on the basis of different years and dates and months, etc. And on y axis we will bring appliances. So you can see it is giving us this simple information because currently we have data of only 1 year. So if we remove year from here, we'll see we have information of 2 quarters. If we turn drill down, then you can see for different months. So in the month of January, the total watt hour energy consumption is lower. In February, it is higher. It is highest in March, reducing in April, and then lower in May. So this way, we will be able to see that. We can copy the formatting here, and here we can drill down further by day wise also. So on the 16th day of a month, it is higher. So this way you can select, and when you are on the highest level of drill up, you can expand your selection like this also. So here you will be able to see January, February, March, April, May. So you will be seeing the quarter wise also. In general tab in title, we will simply select our font color. I will just select little bit darker color of the same shade. This is sum of appliances by million, by month, where we can also write total energy consumption by quarter, or instead of changing here, because it is dynamic, so instead of changing here we will simply write energy consumption. So this shows us that this particular variable has effect on total energy consumption. So this is one thing. Now let's do with another variable. As we have checked for date, we also have different temperatures. These are inner temperature sensors, like inner temperature sensor T1, T2, T3 and so on. So we will simply copy this chart, make a copy here, and let's fill up. So here what we can do, we can simply change it to scatter plot, remove date from it, or actually we have to change it here. So we'll simply change it to scatter plot. On x-axis we'll keep the energy consumption. Actually on y-axis we will keep the energy consumption, and on x-axis we can keep any of the temperature sensors and see on the basis of temperature sensor. We will use don't summarize to see all values, and don't summarize here as well. So this is how you can see on the basis of T1 how if the temperature value is increasing, we can see a slight increment in the energy consumption as well. You can add a trend line here to see some relationship. Similarly with other temperatures also, like for example if we have T2, so in case of T2 you can see, but you always have to use don't summarize. In case of T3 also you can see. So for different sensors you can see how energy consumption varies, and here we will actually write energy consumption by temperature or inner temperature. As we have done for inner temperature, we can also create another scatter plot here, and in this scatter plot let's keep three of them together. We'll see how to add more. So here we will use the T out, which is the outer temperature on x-axis. We will use don't summarize, and on y-axis we will bring appliances, which is energy consumption. So this is how on the basis of outer temperature it varies. We'll simply call it outer temperature and energy consumption relationship. Formatting the painter, we can apply the same styling here, and we can create trend analysis here also. So here we are seeing slightly upwards trend when outer temperature is more and energy consumption is kind of increasing. So for example in January we saw that the temperature was more, so we have information, sorry, temperature was less, so energy consumption was also less. So we can also see that month wise what is temperature, so for the area for which it has been collected. So here if we just keep, we remove everything and just add month here. So in date hierarchy we only select month here on x-axis, and here we select outer temperature. So and we will use a line chart, and here only one month is actually selected. Maybe some filter is applied So actually on the basis of this filter, so you can see in January temperature is lower and this is higher. So you can see month wise temperature here, and in month wise temperature we can easily see, actually we have to change it here, let me correct that. As we have created or created a simple relation plot between energy consumption and inner temperature and outer temperature. In the similar way, we can also find out for relative humidity and pressure, but there is one more way. Let's say relative humidity inner and relative humidity outer. So we can simply click here and we can create a new group, and in the group it will create group of the relative humidity first sensor. We can go to size of bins, instead of that we can go with number of bins, and actually there are 55 bins, that means 55 bars will be created. We will just divide it into 10 groups, so every bin size will be a relative humidity of 0.6%. Similarly you can create for other sensors also. So we will take one of them and let's use the stacked column chart here, and in the stacked column chart on x-axis we can put relative humidity bin, and on y-axis we can put the appliances. So this will show us total energy consumption by relative humidity value, inner relative humidity value. So you can see for relative humidity bin of around 38 to 40, the energy consumption is highest. Now what we can do is, this is RH bin, so we can also add RH out here, and in that case you will be able to see for different parameters, but here we actually have to create separate charts like we have done it for here for inner and outer. So just for inner we will use the same styling, so we will copy the formatting from here, apply it here. This is sum of appliances by RH1 bins, and then when we will copy it we will simply use RH out. So for RH out also we will create a new group. Here also we will do the same thing. We will say we want 10 bins, and here on y-axis we have sum of appliances and RH out bins will be on x-axis. In case of outside relative humidity, you can see when humidity is very high, outer humidity is very high, in that case energy consumption is more. People may turn on air conditioners to reduce the humidity, and that's why you can see in this particular range it is more for inner uh, different inner sensors. As we have created energy consumption by relative humidity outside, we have also done it for wind speed. We have just created wind speed with 5 bins, and the group we have created number of bins is 5, and you can see when wind speed bin value is 2.80, in that case we have highest energy consumption, and when wind speed is very high energy consumption is low. In case of lower wind speeds also energy consumption is little bit higher. We can do the same thing for visibility. So for visibility also we will create 5 number of bins, and we will copy this For different visibility ranges, we will replace visibility bins here, and we will just change it like this. So you can see for different visibilities, in the visibility of 40, and unit will be given here. Visibility is given in kilometers. So you can see for visibility of around 40 kilometers, when it is there, then energy consumption is high. That is for higher ranges of visibility. In case of lower ranges of visibility, you can see energy consumption is lower. We can also select average energy consumption. So average energy consumption on the basis of visibility, you can see here. So energy consumption by wind speed is given. So we will write average energy consumption by visibility. If you want for these charts, you can also enable data labels. So you will be able to see those values as well. Not just that you will be able to see the bars, you will be able to see those values as well. So this type of setting can be done easily here. We also have T dew point in Celsius. So we will create the same chart for T dew point as well. So for T dew point also we will enable the new group. You can also create conditional values, like for, you can see it has value -6 to 15 degree. You can write something like very cold, cold. So that's why the number of bins that we are creating, suppose 5. So it will start from a lower range. So lower ranges will be very cold temperature, normal temperature, or hot temperature. This type of groups will be created. And here we will simply replace it with T dew point. And you can see, in case, what is the average value of energy consumption by different T dew point. So we will write T dew point. Similarly, we have done as energy consumption by pressure for lights, that is given here. So you can see in case of lights also, the value is in watt hour. So for light loads, you can see on an average and energy consumption is more in case of 60 lights. So this way, this is basically average energy consumption by lights in watt hour. We also have RV1 and RV2 here. So we can also include them. These are random variables which are added by people who are doing this analysis. So on the basis of these, this is just to enhance the performance of the model. So for RV1, RV2 also we can see. So this is what you will get when you will not group them. So you will see all the bins, many bins will be there, and if you will group them, you will see clear groups like this. So we will just keep one of them. So this is average energy consumption by RV1. So this way we can simply say that if we have selected average energy consumption or sum of energy consumption, so almost all of these variables have some effect, like how their different values are distributed for different values of energy consumption tells us that these have some effect on our final output. By taking some time, what we can do, we can change color in each chart over here. So whatever bars we have used, we can select this color because we are using this as a theme color. In case of line charts, you have to go to line. In line you will find color. From here we can select this, and for bars it will be inside the column. So you can select it here. Here it is in bars. So Wherever you find them, you can just change the color according to theme. And here also we can change. Now here we have kept only one variable, just to let you know that, let's say this is energy consumption. In some cases the lights load can also be considered as a value to consider. So that's why this is energy consumption, and we can also say lights energy consumption. So you can select that. So this is a simple appliance energy analysis prediction. From here we try to understand which features have effect on our target value, which is energy consumption given as appliance, and then after finding that, we use them in the data models.